This video brings together all of our understanding of transformations covered in the previous videos and applies them to sketching a function like this. It allows us to understand what the function should look like before we even start, and therefore gives us the capacity to sort of preempt what we would expect to get as our values out. So this function here has been written in what we call turning point form. We know that from previous work. But now we can use our understanding of transformations in order to make more sense of what we're seeing. So for example, we can see a negative outside of this square here. So we know that the shape of this graph is going to be like that. We can also see that there is a horizontal translation of 1 unit to the left, because it says +1 there, and a vertical translation of 4 units up. So that's true, remember, of every single point, but specifically it's true of the turning point. Now in a base graph of f of x equals x squared, the turning point is 0, 0. So that means that the new turning point must be 1 unit to the left for the x coordinate and 4 units up for the y coordinate. So straight away, we can say that the turning point, TP, is going to be -1, 1 unit to the left, and 4 units up. No need to do anything more. And PS, if it asks you for the axis of symmetry, that is just the x coordinate written as an equation, x equals -1. Please note you do need to write x equals -1. The axis of symmetry is not -1, that's just a number. X equals -1 is an equation which can be graphed. So you've now got a decent sense of what the graph is going to look like, something like this. But to complete the picture, we need to work out the y-intercept and the x-intercept. So once we've determined the shape, once we've determined the turning point, we can then say, well, the y-intercept is when x equals 0. That would make y equal to minus 0 plus 1 all squared plus 4, which is equal to -1, 0 plus 1 is 1, squared is 1, plus 4, which is equal to +3. So that's the coordinate 0, 3. I like to write minus coordinates so that I'm aware that these are coordinates that I'm writing down and not just numbers. The x-intercepts, if they exist, and we can pretty much at this point suspect that they do exist based upon the shape and where the turning point is. So the x-intercepts are at y equals 0. So we set y equal to 0 and solve. 0 is equal to negative x plus 1 all squared plus 4. Subtract 4 from both sides to get -4 is equal to negative x plus 1 all squared. Multiply both sides by -1 and we'll get 4 is equal to x plus 1 all squared. That's what I'm aiming for, to get the squared term all by itself. And now I'm going to square root both sides, and the square root of 4 is positive or -2. So we've got x plus 1 is equal to plus or minus 2, which means that x plus 1 equals 2, which gives us x equals 1. Or we've got x plus 1 equals -2, which gives us x equal to -3. So that's the coordinate -3, 0. Okay, so we know the shape we're looking for. We know the turning point. We know the axis of symmetry. We know the y-intercept and the x-intercepts. They don't always exist, the x-intercepts, but they do in this instance. Now we can go about drawing or sketching our graph. We're going to use a ruler and make sure it's nice and straight. We're going to label our axes. We are then going to roughly position our graph. So it's -1 across and 4 up, so around about here somewhere. I'm then going to draw my curves in, like so, making it as symmetrical as you can. And then I'm going to label my points. So that's going to be -1, 4. That's going to be 0, 3. That's 0, 1, and that's my 1, 0, and that's going to be minus 3, 0, and that's my sketch done. Just for the sake of it, I'll just point out here that was a little bit of a mistake up in slide 14. It should have said 1, 0, not 1, 2. That's my bad. Okay, and we are done.